Hello everyone, and welcome to another exciting episode of Cryotos Maintenance Management. I'm your host, Gopi, and today we have a special guest joining us. Please welcome May, a maintenance management and IoT expert. May, thank you for being here.
Thank you, Gopi. I'm thrilled to be part of this podcast and discuss the fascinating topic of how predictive maintenance reduces plant downtime.
Excellent. So let's dive right in. May, could you start by explaining what predictive maintenance is and how it differs from traditional maintenance approaches?
Certainly. Predictive maintenance is an advanced maintenance strategy that utilizes real-time data and analytics to predict equipment failures before they occur. It involves continuously monitoring the condition of assets, collecting data, and analyzing it to identify patterns or anomalies that indicate potential issues. By proactively addressing these warning signs, organizations can schedule maintenance activities at the right time, avoiding unexpected breakdowns and reducing plant downtime. In contrast, traditional maintenance methods typically involve periodic inspections or fixed-time maintenance schedules, regardless of the equipment's actual condition. This approach can be inefficient, as it may result in either unnecessary maintenance or, worse, missed maintenance. That could lead to unexpected failures and costly downtime.
That's a great overview, May. So, how does predictive maintenance specifically help in reducing plant downtime?
Predictive maintenance offers several significant benefits in minimizing plant downtime. Firstly, by detecting early signs of equipment degradation or malfunctions, it allows maintenance teams to take proactive measures. This proactive approach enables them to schedule maintenance activities during planned downtime or at a convenient time that minimizes disruption to production. Secondly, predictive maintenance enables the optimization of spare parts inventory. With real-time data and predictive analytics, organizations can accurately forecast when components are likely to fail and have the required parts available, avoiding delays in acquiring replacements. Moreover, predictive maintenance helps in improving equipment reliability and extending its lifespan. By addressing emerging issues early on, organizations can prevent small problems from escalating into major failures that require extensive repairs or replacement. This not only reduces plant downtime, but also saves on costly capital expenditures.
That makes perfect sense, May. It seems that predictive maintenance can provide a significant advantage over reactive or scheduled maintenance. Are there any particular technologies or tools that enable effective implementation of predictive maintenance?
Absolutely, Gopi. The implementation of IoT plays a crucial role in enabling effective predictive maintenance. IoT sensors and devices are deployed on equipment to collect real-time data on various parameters such as temperature, vibration, pressure, and performance indicators. This continuous stream of data is then analyzed using advanced analytics techniques, such as machine learning and artificial intelligence, to identify patterns, anomalies, or deviations from normal behavior. Furthermore, cloud computing and edge computing technologies facilitate the storage, processing, and analysis of large volumes of sensor data, providing organizations with actionable insights in real time. These technologies enable maintenance teams to make data-driven decisions and take preventive actions promptly, reducing plant downtime and optimizing maintenance activities.
Excellent insights, May. It's fascinating to see how technology advancements have revolutionized maintenance practices. Before we conclude, could you share any success stories or examples where predictive maintenance has significantly reduced plant downtime?
Certainly, Gopi. One notable example is the manufacturing industry, where predictive maintenance has demonstrated remarkable results. In one case, a company implemented predictive maintenance for their critical production line machinery by analyzing real-time data from sensors and leveraging predictive analytics. They were able to identify an impending failure in a key component of a machine. This allowed them to replace the component during a planned maintenance window, preventing a catastrophic breakdown and saving several days' worth of downtime and lost production. Similarly, in the energy sector, predictive maintenance has been instrumental in optimizing the maintenance of wind turbines. By monitoring the performance and health of the turbines, Operators can proactively address issues such as imbalances or abnormal vibrations before they escalate. This has led to significant reductions in unplanned downtime and maintenance costs.
Those are impressive examples. May, it's evident that predictive maintenance holds tremendous potential for various industries. Thank you so much for sharing your expertise with us today. It has been a pleasure having you on the show.
Thank you, Gopi. It was my pleasure to be here and discuss this important topic. I hope our conversation helps organizations understand the benefits of predictive maintenance in reducing plant downtime and motivates them to explore its implementation further.
That concludes today's episode of Cryotos Maintenance Management. We hope you found the discussion informative and gained valuable insights into the world of predictive maintenance. Stay tuned for more episodes where we uncover the latest trends and technologies in maintenance management. Until then, stay smart and proactive in maintaining your assets. Goodbye.